Okay, well here we go, stats friends. We are now moving forward into binomial distributions, part C, example 1, part C, and we'll build off of what we've established before. So anyway, in parts A and B, we found the probability that this basketball player is going to hit 3 shots out of 5, and then we figured out the probability all the way from 0 to 5. Now, when we transition to part C, it's really important that we pay careful attention. We still have the fact that Mario is shooting, Super Mario is shooting 5 shots. But here's the deal. When we get to part C, and again, you will have the PDF in front of you, it says, what's the probability he will miss exactly 1 shot? Miss! Look at that. So when they talk about missing shots, you know what that does? That changes the definition of success into missing a shot. I want to remind you that the P, when we set this up, is the outcome under consideration, the outcome that the question mentions, all right? So when the question mentions missing shots, you know what that does? We're considering it a quote unquote success for Mario to miss a shot, all right? Maybe Mario plays for our opponent. Maybe he plays for misery, and we want him to miss the shots. So the point would be, missing a shot, which is a 20% probability, would be P, and therefore Q would be 0.8. Now this was set up under the assumption that X was hitting shots, so this isn't really valid, but we will talk about how it relates. I left that up from part B, and we'll see how it relates, but let's pretend that's not even there now, all right? So we've got 5 shots. We want to know how many he misses, and therefore there's the P and the Q. All right, so part C here, when it says what's the probability that he will miss exactly 1 shot, that means that the variable X, which this time is missing shots, is equal to 1. All right, so if we reason it out like the ones we did earlier, we would say, Mario, I'm going to give you 5 shots. You can choose any one of them to miss, and I don't care what order. So that would be the combination of 5, choose 1. 5 shots, choose any one to miss. I don't care what order. That's why it's a combination again. All right? Now, you're going to miss, which has a 20% probability, 1 shot, which means you're going to hit, whoops, that's 0.8, which means you're going to hit 0.8, 4 shots. What do you guys think? Does that make sense to you all? Yeah, it really does! Okay, thank you so much. You guys are so involved in this, and I really appreciate your involvement. So the point would be that if you go ahead and push the buttons, and we talked about this before, that's a combination. You're taking things to powers. Your calculators are all different, but you know how to take a number to a power. You learn that in college algebra. It's just algebra. And if you crunch this out, I'll do this in my head, I believe you'll get 0.4096, as if it was a standalone question. Now, okay, I'll come clean. I cheated. Look. In part B, we did this, where X represented hits. But pretend this didn't exist. That's how you would set this up to work the problem. But, okay, let's cheat now. Let's look back at part B. When X was hitting, wouldn't missing 1 shot be the same thing as hitting 4 shots? If you do the math on that, it's not a coincidence. That comes out to be the same number when we did hitting 4 shots. Because hitting 4 shots is the same thing as missing 1. But again, if you didn't have that, this is how you should set this question up. I hope that made sense. We'll now see you very soon for part D. Good job, everybody.